Hello, in this episode of Exploring Rust, I'm going to take a look at deref coercion or implicit deref coercion. And I'm also going to take a look at how we can create types that you can dereference to get some value associated with the type. This basically corresponds to a particular page in the Rust documentation. I've already written this up as an article. I'm going to add the video to this, so I'm basically going to be doing this stuff here. So the motivation for this is something that we can do with box. Let's create a box. So if I say let, I don't know, value equal box : new, I can pass some value to that, like, well, it can be anything, an integer or something else. And then we can print that like this. If I put some curly brackets in like that, then I can just put value here. Let's try to run this. So you can see that works, and what we actually get is 7. Instead of it printing out some kind of weird box thing, we actually get the value out of box. We can also get the value out of box, and this is also a little strange, with the dereference operator like this, which is the kind of thing you could do in C or C++ if you have a pointer. So if I run this, this also works. Now, this first thing here, we're not going to be able to get that to work exactly like this, because apparently there's some kind of built-in compiler support for certain types in the standard library. I don't know how that works, but that's the answer I got back from Microsoft Copilot on this topic. But I think if we put a reference there, that will also work. Let's try that. So you can see that works as well. So here we're getting automatic dereferencing. We're dereferencing once to get the actual box that's being created by this new method. And we're dereferencing a second time to get the value inside box. And there's also a puzzle there about why dereferencing a box actually gives us the value that it contains, so to speak. So by implementing our own type, we are going to be able to get this to work with the reference symbol in there. Let's get rid of this stuff. It took me a while to work through the Rust documentation page on this. I think mainly because I've already kind of forgotten or half forgotten a lot of the stuff that I looked at earlier on. So I'm going to take this step by step and build it up from the basics here. First, what I want to do is define a tuple struct. Let's say here, struct, I'll call it thing. So remember, a struct has actual named fields. That's kind of similar to C or C++. A tuple struct doesn't have named fields, so we just put here what kind of types of things are going to be in it. So I could say, for example, that we'll have a single i32 in this tuple struct. I think that will work. I'm just going to check because I'm not 100% sure. Yeah, I'm getting just unused variable warnings. So as always, I'm going to have to do this. I'm going to have to turn them off. All right, so let's put here allow unused. And now that should compile without any kind of errors or warnings. Oh, I typed allowed by mistake. Allow unused. Let's try again. Okay, finally we are there. So I can construct one of these. Let's say let thing with a lowercase t equal. How would I actually construct it? I suppose thing like this, maybe? Just put a sort of, put the name of it, and I think that would act as a constructor. I'm already having doubts. But fortunately, I can consult my notes if I get into too deep water with this. Let's try to print it. Can I actually print it? I don't know. Yeah, what I want to print here is the first and only field of this tuple struct. And to refer to the fields of tuple structs, since they don't have names, we can just use this dot notation like .0. That might work. Yeah, it does actually work. Okay, I hadn't misremembered. I'll just do cargo format. All right, so now what if we want this tuple struct to have a single field that can be any type, and we want the type to be inferred when we do this? That's pretty easy to arrange. Whether I can remember the syntax for it is another question. We need to put a generic type somewhere. I'll try putting it there and see if that works. And then this would then be t. So this generic type, we want it to be inferred. and whatever gets inferred, we want a single field of that particular type. So in this case, we want t to be inferred as an integer. Let's just try that. So if I run it, yeah, I think I just put this in the wrong place. Let's cut it from there and try putting it there and see if that works. Yeah, that actually works. So that's the correct syntax then. We should be able to explicitly specify the type for this in various places. I think when you use a kind of generic type as part of a type definition, then you just have the diamond brackets around the type. But if you use it in a constructor or function call, I think you generally need this double colon syntax. So I would expect that we could do something like this. Let's try it and see if that works. Yeah, that also works. And of course we could specify the type here if we want, but it's really not necessary. The type would be presumably thing of I32. Let's try that. Yeah, and that works just fine. So far that's just a normal tuple struct. Now here we can't use the syntax that we typically use with box. We can't use the new kind of syntax. So to enable that, we need to provide some implementation. We need something like impl thing, and then we have implementation of the new method in there. Now in this case, new is going to have to work with type t. So we specify the type directly after this impl here. And because thing is a generic type now, it's something where when you create it, a generic type has to be specified like this, or you have to let it be inferred, one of the two. And because we want the inferred type to be this, we have to put the t here as well. So actually, after I went through the whole example in the documentation, I had a lot of questions and I just asked Microsoft Copilot, and that's stuff that I'm basically telling you now. I've sort of cleared it up in my own mind as much as possible. So now we can create a new method. Let's say function new, and I guess that's going to accept a value of type t, if I remember well. And what's it going to return? It's going to return a thing with the parameterized generic type of t, so probably this. And then for the return value, we just need to say thing. I guess we put the colon in there, and that's of type t, and then we just put the value there. So if we don't put a semicolon there, this expression will become a return value. Not sure if that's correct, but let's try it. Oh, it does actually compile. I didn't think it would, to be honest, but yeah. So there's nothing special about this new keyword. It's actually, it's just a method. To call it new is just purely a convention in Rust. Now let's try that out. So I'm going to say let thing equal thing : new, and we'll supply a value in there and see if it works. And I can also print it out like this with this. I'll try that. Yep, and it works. So good so far. Now I want that kind of behavior with box to work. So if I have a thing like this, instead of having to know how it's implemented and referencing its first field via this dot notation, what I want is to be able to dereference it with the dereference operator, the asterisk, and I want that to give me the actual value that's in it. And for that I need some more implementation here. Whether I'll be able to remember this, I'm not sure. I'll give it a go, but I'm probably going to have to refer to my notes. So we want an implementation which implements the deref trait for thing, something like this. And I will need to import deref. Let's say up here, use standard, I think it's ops and deref. That looks promising. Then I can say implement deref for thing. Do I need to put type stuff there? Maybe. And then we've just got one method, function deref. Let's put in the uncontroversial bits first. So I will need to specify the type here, because what this dereference operator needs to return, I suppose, is something of type t. And does that not imply that I need to mention t here, and I need to say it's going to be for thing of type t, I would imagine. And then what would I return here? Now I remember there's some self references going on here. So to actually return the value in the thing, it's going to have a reference to self. Now I've just remembered something that I don't 100% understand, but it kind of makes sense, which is that we need some sort of type field here. Something like type target equals t. So this is a way apparently of specifying an associated type, and it's going to be the type that we return. So we don't say t here, though I would have thought that would work. Why wouldn't it work? I don't know. But we have some syntax like self with a capital S and then target, something like that. And what do I actually have to return? Presumably self.0, just the first field. I'm really not sure if this is correct, but let's just try to compile it and see what actually happens. So I need a semicolon after target. We'll try this. Cannot find type target in this scope. Oh yeah, that should probably be T, right? And we'll try that. Now it's complaining about a move. So yeah, I remember the documentation mentioning this. We don't want to move the value out of thing here, which I suppose could happen. I'm not sure if would that actually happen with an integer? I don't know. But with a string, clearly that could be problematic. And what we want to do is actually return a reference to the existing type that's in there. We don't want to move it out of the thing. So this probably has to be a reference, maybe. Let's try that. Wow, that actually compiles. I may actually have remembered this correctly. Well, let's see if it actually works. So instead of writing thing naught here, I'm going to write star thing. And so the hope is that by implementing the deref trait, that will actually give us the field in thing. So, it's like we're dereferencing a reference, except we're not. We're using the dereference operator and it's somehow giving us the value that thing contains, just as it would with box. So here's the moment of truth. And it works. We've got 99 coming out there. So there are some things that I don't totally understand here, but it's not too bad. Why do we have this self thing here, self : target? Couldn't we get rid of this? Couldn't we just get rid of that and write reference to T? See, I would have thought that would work. Let's try it. Well, it clearly doesn't work. It says missing target. So I guess it must be part of the specification of the deref trait that this target is actually required. Although target quite clearly boils down to this type T in the end. And I guess this self syntax, which I'm not familiar with either, is just some way of referring to the type itself, and then we can get the target out of it in the same way that self with a lowercase f refers to an object of this type. So I suppose it all does sort of make sense. Now the final thing that I want to show you, and I feel now we're on home ground, this is the home run, whatever you call it, this should be the easy bit, is that, see, this doesn't work, but something very similar can be made to work. Let's try this. So we get a problem here. And what I understand is that this isn't going to work because it works with box because of some built-in compiler support for parts of the standard library or something. I hate it when there are special exceptions for built-in stuff. It feels like there's smoke and mirrors there, but I don't understand Rust well enough to actually criticize it. Maybe it's not as bad or unusual as it seems. Let's just try putting a reference symbol in there and see if that works. So if I run this, yeah, that also doesn't work. So I'm going to go back to how it was before. We're not going to get this to work. We haven't got built-in compiler support for it. Apparently, if I did want this to print without the dereference operator there, apparently I could do it by implementing the display trait. I had a quick look at that. It looked pretty complicated, so I'm not going to get into it. But there is something interesting that does work. Let's create a function here, and I'll call it something like print thing. I'm going to make print thing accept a value, which actually I'll just call that thing as well. And that's going to be of type i32. Actually, maybe this was a bad choice. I might call it print value. and I might call this value. That seems to make more sense. And what we can do with that is just use print line, for example, to print a value. So I'll just pass value in there. So clearly this expects an I32, not a thing. But what I think I can do is if I write print value, so I can't pass thing to it. That doesn't work. Let's try that. If I run this, yeah, that definitely doesn't work. We would have to put a star in here to get an I32 out of this. But look what happens if I put a reference here. Let's try that. So I'm going to run that. Still doesn't work. Well, this did work when I tried it earlier. Oh, is there an error somewhere else or something? No. I swear this worked. Let me check my notes. Okay, I got it. This has to be a reference to an I32. Now let's try that. Clear this and run. And now it works amazingly. Let's just try it without this. I don't think that will work. Yeah, that doesn't work. But this does work. There you go. Why does this work? Well, this has to do with implicit deref coercion. Under some circumstances, Rust will dereference a thing as many times as necessary. It will do that implicitly, and it will do it at compile time, so there's no impact on efficiency. And if you think about it, this is actually getting dereferenced twice. So we're passing it a reference to a thing. When we do that, it has to be dereferenced once just to get a thing. It has to be dereferenced again, making use of the implementation of the deref trait to get at the value in thing. So Rust will just keep dereferencing it until finally we get at the value. And of course, that's only going to work if dereferencing it some number of times will actually produce a value of the right type. So that's implicit deref coercion, which is pretty crazy. And that does explain why in previous videos I've noted that sometimes you can get the same result by using the dereference operator and not using it. And I think I even tried once and found that I could use two dereference operators or one or none at all, and it still worked. So that's the answer to that problem. There is this thing, implicit deref coercion. So that's it for this video. Do check out the write-up at blog.caveofprogramming.com. I will also put a video on here where you can watch it without any advertising. And until next time, happy coding.